Hi students, welcome to the Elements of Mechanical Engineering course, lecture class 3, the same continuation of internal combustion engine. In the lecture class 1 and lecture class 2, we have understood about the basics of internal combustion engine, and also in lecture class 2, the working principle of 4-stroke petrol engine. So today's class will be on discussion on working principle of 4-stroke diesel engine, working principle of 2-stroke petrol engine, working principle of 2-stroke diesel engine, differences between 4-stroke and 2-stroke engine, differences between petrol engine and diesel engine. So now the working of 4-stroke diesel engine. It works on the constant pressure cycle. It is also called as a diesel cycle. But in the case of 4-stroke petrol engine, it works on constant volume cycle. But in the case of 4-stroke diesel engine, it works on constant pressure cycle. So this diesel engine we call a CI engine, compression ignition engine. Compression ignition engine, combustion takes place because of fuel injector, not by the spark plug, because of fuel injector. So in the case of 4-stroke petrol engine, we use the spark plug. In this we use only fuel injector, and charge is air only. In the case of petrol engine, during suction stroke, charge is air plus fuel, but here charge is only the air alone will be entering into the cylinder during the suction stroke. Fuel is sprayed in the power stroke. So looking into the figure, first is suction, next is compression, next is expansion, last one is exhaust. Same 4 strokes are there, same 2 revolutions of the crank. So for every 2 revolutions of the crank, we will get a 1 power stroke, just like previous case, that is 4-stroke petrol engine, and the crank will make 2 revolutions. TDC means top dead center, BDC means bottom dead center. We have IV inlet valve, EV exhaust valve. Air, see, you can see the air direction, air in suction stroke. Looking into the first figure, air alone enters inside the cylinder. So the piston movement is from top dead center to the bottom dead center. You can see downward arrow. So air alone, because of the vacuum which is created when as the piston moves from top dead center to the bottom dead center, partial vacuum is created, air is sucked inside the cylinder. So in the compression stroke, the movement of the piston is bottom dead center to the top dead center. That is the upward direction. You can see the upward arrow. So inlet valve, in this case, inlet valve is closed and exhaust valve is closed. So their inlet valve, the suction stroke, inlet valve is open, exhaust valve is closed. So in the case of compression stroke, inlet valve is closed and exhaust valve is also closed. So the crank makes 1 revolution. Totally crank makes 1 revolution. So the compression of air takes place. In the compression stroke, compression of air takes place. So next, in the spark plug, in third one is the expansion stroke. The spark plug, actually in the petrol engine, spark plug produces the spark, but in this we don't have the spark plug, we have the fuel injector. You can see the fuel injector here. The fuel injector sprays the diesel in the form of fine spray, So in the compression, the air is compressed because of that high temperature. Air gains high temperature and high pressure. When the fuel, that is a diesel, if you spray in the form of fine particles, it catches a fire, combustion takes place, hot gases are produced. So because of this, the piston starts moving from top dead center to the bottom dead center. You can see the downward arrow. So now 1.5 revolution of the crank completes. Next, inlet valve and exhaust valves both are closed. And the last one is the exhaust stroke. In exhaust stroke, so the gases will go to the atmosphere. You can see here exhaust burnt gases will go to the atmosphere. Next, here the inlet valve is closed, exhaust valve is closed, exhaust valve is open. Because when the exhaust valve is open only, you can send the gases to the atmosphere. So inlet valve is closed, exhaust valve is open. The movement of the piston is from bottom dead center to the top dead center. You can see the upward arrow also. So thereby you will get the one power stroke for every 2 revolutions of the crank. It is so 4-stroke petrol engine, 4-stroke diesel engine, working principles same, except that the fuel injector we are using here in the case of diesel engine, but there we are using spark plug. And in the suction stroke, air alone enters, there air plus petrol enters here in the case of 4-stroke petrol engine. Next, in the spark plug produces spark, but here spark is plug is not there. Fuel injector will be sprayed in the form of fine spray in the case of in the expansion stroke. The expansion stroke. So movement of the piston is a suction stroke TDC to BDC. Inlet valve is open, exhaust valve is closed, crank rotation is off. Compression stroke BDC to TDC. Inlet valve condition is closed, exhaust valve conditions are closed, crank rotation is 1. Expansion stroke TDC to BDC. Inlet valve, exhaust valve both are closed condition. Crank will be 1.5 revolution. Next last one is exhaust stroke BDC to TDC. Inlet valve is closed, exhaust valve open, crank rotation is 2. So 2 revolutions of the crank for every 1 power stroke. So this is you can see the figure. Next, PV diagram is a constant pressure cycle. Looking to the figure here, so here you can see this is 1 and this is 2, 3, 4. So 1, 2 is adiabatic compression, 3 to 4 is a 3 to 4 is adiabatic expansion. It's a constant pressure cycle. Constant pressure cycle means see the pressure remains the same. Pressure is not changing. So this is the pressure. This pressure it remains the same. Pressure will not at all change. That is a constant pressure cycle. PV diagram. So this you should draw when they ask an examination. Is a TS diagram, temperature entropy diagram. Is coming to the 2-stroke cycle engine. In 2-stroke cycle engine, we have 2 strokes. First stroke is upward stroke. In upward stroke, compression, suction, ignition takes place. In second stroke, downward stroke, expansion and exhaust stroke. So first stroke is upward stroke. That is it moves from bottom dead center to the top dead center. Second stroke is the downward stroke, expansion stroke. Downward means from piston moves from top dead center to the bottom dead center. So in this engine there is no separate stroke for the suction and exhaust. Okay, one cycle is completed in 2 strokes of the piston in 1 revolution of the crank. So 2-stroke cycle engine, same thing. First stroke is upstroke, compression, suction, ignition, BDC to TDC. Second stroke is the downward stroke, expansion, exhaust stroke. So movement of the piston is TDC to BDC. So 2-stroke engine, in this 2-stroke engine we have ports. We don't have the valves here. Instead of valves we have the ports. So ports are present here instead of valves. So inlet port, exhaust port, transfer port. So inlet port allows the charge inside the cylinder. Exhaust port, and through exhaust port exhaust gases will be sent outside. In transfer port the charge will be transferred from the crankcase to the cylinder head. So now one important concept is the scavenging process. Scavenging means what? Scavenging means so removing the exhaust gases, burnt gases completely. So we are just removing entire gases. We are cleaning. It is actually cleaning. Scavenging means it is a cleaning. Scavenger. So what is the meaning of scavengers? Scavengers means people who just sweeps in the roadside. We can call them as a scavengers. They means they will clean the road, right? They are called as scavengers. So scavenging means the process of removing the burnt gases from the previous cycle of operation. So first cycle is over, second cycle it has to start. So during that time the scavenging process takes place. That is, when you send the fresh compressed charge for the second cycle, the already burnt gases, which has not gone to the atmosphere completely, it will be expelled. So it will be expelled by the allowing the fresh compressed charge. Okay, that is called a scavenging process. So it is applicable only for the 2-stroke engine, that is petrol engine as well as diesel engine. So scavenging is the process of removing the burnt gases with the help of fresh compressed charge is called as scavenging process. I will give one more example also for this. Say for example, if you have a sump is there. So in sump water is there. Okay, full of water is there. Sometimes water will not be there say like 50% water is there, but sump is very big sump. In such cases, you wanted to clean, some particles are there, paper particles, some contaminants, impurities are there, you have to clean. So what best we can do is, we can just fill the sump with the help of water. So all the floating materials like paper, dust, everything, all the floating material, once it is overflowed, all these particles will come out. Okay, then water will be fresh water. So we can do that. Even over a tank also we can do, even though it is not possible for you to clean very oftenly. Then you can just apply this technique, that is, you can overflow the water. Okay, for 1 or 2 3 minutes, depending upon the size of the tank, you can overflow the water, so that the particles which are there, that will come out, it will go to the outside. Okay, so that is a scavenging. So the same way, the hot gases, these hot gases are cleaning process are done by sending the fresh compressed charge into the cylinder head. So cylinder piston, actually it is made up of a special dome shaped one. Okay, it is a dome shaped one piston. You can see dome shape. So this is a dome shaped piston, a dome shaped piston. Okay, so this a specific shape is given to a piston as shown, as it is called as deflector, which helps to prevent the loss of incoming charge, and also it helps in expelling the hot gases effectively to the atmosphere. So deflector has two functions. It helps in preventing the loss of incoming charge, and also it helps in exhausting the hot gases effectively. That is the function of deflector. So two things you have to remember: scavenging and deflector. Scavenging is the process of removing the hot gases with the help of fresh compressed charge. That is called a scavenging process. And as deflector is a special arrangement, a special design is given to a piston, a dome shaped piston, which helps to prevent the loss of incoming charge, and also helps for exhausting the hot gases effectively. Okay, so through inlet port, fresh charge from the carburetor is taken to the cylinder crankcase. Through the transfer port, fresh charge from the bottom of the piston is supplied to the cylinder. Okay, this deflector deflects the fresh charge to the top of the cylinder, expelling the burnt gases through the exhaust port. Then the piston is pushed downwards, and the cylinder is repeated. Cycle is repeated. So we have two strokes again. One is upstroke, BDC to TDC. Second is one downward stroke, the DDC to BDC. So two-stroke engine features we have to remember. Two-stroke engine is a small, light, and mechanically very simple. Compared to four-stroke engine, it is very small one, light in weight, and mechanically it is very simple. Mechanically very simple means no moving components. Components are very less. Okay, components are very less. That is why you can say is mechanically very simple. The efficiency of this engine is very low, and it's more polluting than four-stroke engine. So as regards to power cubic centimeter, it has more power compared to four-stroke engine, because the crank makes only one revolution. For every one revolution, you are getting the one power stroke. But in the case of four-stroke engine, crank has to make two revolution. That is why CC is more for this two-stroke engine compared to the four-stroke engine. So coming to the working principle of two-stroke petrol engine, you can see here two-stroke petrol engine. We have only two strokes, A, B. This is the first stroke. For A, B comprises first stroke. Next C, D is the second stroke. First stroke means what? Upward stroke. Upward means upward direction. You can see the arrow. You can see the arrow. You can see here. This is the upward direction arrow. This is also upward direction arrow. So here the bottom dead center, the piston moves from bottom dead center to the top dead center. Here also piston moves from bottom dead center to the top dead center. We have a spark plug here. So this is exhaust port is closed, inlet port is closed, transfer port is also closed. Here transfer port is also closed, exhaust port is, inlet port is closed. So first stroke is upward stroke. So upward stroke means the piston has to move from bottom dead center to the top dead center. Okay, in first stroke, upward stroke, compression, suction, ignition. Three things will happen. Remember, in first stroke, compression, suction, ignition. First is compression. Compression means what? See, one more thing I'll tell you. You should assume that already in this cylinder head, we have the charge. Charge means what? petrol plus air. Okay, air plus fuel, air plus petrol mixture is already there in this cylinder head. Okay, in the case of petrol engine, but not in the case of diesel engine. In diesel engine only air. Okay, so in the case first we should assume that already we have charge is present here. Charge is present in the over the above the in the cylinder head. Okay, so now the piston starts moving from bottom dead center to the top dead center. As it moves, okay, inlet port gets opens, exhaust port closes. Okay, the charge which is present here, it is compresses. Okay, charge which is present here, it compresses. That is compression has taken place. Okay, next suction. I told you, compression, suction, ignition. Suction, so once it is moved here, moved to the top dead center, so this charge which is there outside, that is from the petrol tank, the air plus fuel from the carburetor, the charge enters inside the cylinder crankcase. It enters inside. So suction, because suction is created. So suction is created inside this crankcase. We have the charge. We have the charge. Charge means air plus petrol mixture. So compression is over, suction is over. Next, ignition. So now here as I told you, this cylinder, we have the charge. This compresses. As it compresses, more amount temperature of the charge and pressure of the charge increases. At the time you are just producing a spark. Spark plug produces a spark. Then combustion takes place. Hot gases are produced. So these hot gases are produced, and because of the hot gases, what will happen? Because the expansion stroke. Okay, there is expansion. The piston starts moving from the top dead center to the bottom. You can see downward direction. So at the time, expansion takes place, and exhaust gases, some gases are going outside. Okay, so inlet port is closed here. Transfer port is also closed here. Okay, so now here you can see the last one here. Exhaust port is open. Through the exhaust port, gases are going outside, and so already which is there here, the charge which is there present in the crankcase, it starts moving towards the cylinder, that is the piston, above the piston. Okay, charge starts moving upwards, because when it comes downwards, the charge which is there inside this crankcase, it pushes, it compresses, and it makes the this piston will make the charge which is present in the crankcase to move towards the piston, that is the main cylinder head. So that is it will be stored here again. Cylinder is stored, and the one cycle is completed. Now the charge is ready for the second cycle of operation. Okay, so that is what's happening in the two-stroke petrol engine. So first stroke is upward. First stroke is what? Upward stroke. Okay, upward direction you can see. Here. Then second stroke is a downward stroke. Downward direction you can see here. Downward direction you can see. So for compression, suction, ignition takes place in this expansion and exhaust. Expansion of gases and exhaust. So within two stroke we are getting the one power stroke. So this is about the working of two-stroke petrol engine. You can see here. So petrol oil mix. Okay, it will come to this petrol oil. It's a petrol tank. Oil is there. Okay, it will come to this filter. It goes to this. Enter into the cylinder. It will come to here. It will come through inlet valve or inlet port. So this is a piston. So this is a crankcase. The charge enters like this. It gets compresses. The exhaust gases will go outside. Next, working of two-stroke diesel engine. Scavenging is required here. Two-stroke cycle diesel engine are bigger and heavier for their power output compared to petrol engine. They are mechanically simple compared to four-stroke engine. Efficiency of the engine is very low. It is also in same working principle of diesel engine is same. So, but here fuel injector we are using. no spark plug, fuel injector. You can see fuel injector here. Compression, suction, ignition. First stroke, upward stroke. In this, we have expansion and exhaust. Okay, same thing. Working principle is same, but spark plug is not there here. Injectors are there. Next, air alone enters here. Air alone. So fuel injector will be sprayed. For diesel is sprayed in the form of fine spray here. Combustion takes place. Hot gases are produced, and expansion. The expansion gases takes place. We will get a power here, power stroke or expansion stroke in this. So crank makes only one rotation, 360-degree. So exhaust port is open. Through exhaust port, hot gases are produced. So next is difference between 4-stroke and 2-stroke engine. The cycle completes in 2 revolutions. A cycle completes only 1 revolution. Here power stroke is obtained for every 2 revolutions. Power stroke is obtained for 1 revolution of the crank. Here for a given size of the engine, power is produced is less since only 1 power stroke. Okay, here for a given size of engine, power is produced more. Only power produced is more because we will get one revolution of the crankshaft. So heavy flywheel is required, a light flywheel is required. It contains valves in case of 4-stroke engine. So it contains ports: inlet port, exhaust port, transfer port. Next, continuation. Thermal efficiency is high here. 4-stroke engine, thermal efficiency is low. Less rate of wear and tear, high rate of wear and tear. 4-stroke engine is heavy and bulky. The engine is light and compact. Less cooling and lubrication is required. High cooling and lubrication is required. 4-stroke engines are used where the efficiency is of great importance. Here 2-stroke engines are used where low cost and lightweight are prime consideration. So nowadays all are 4-stroke engine only. Even 2-wheelers also 4-stroke engine only. And difference between petrol and diesel engine. So depending upon the particulars of the fuel injection, charge, compression ratio, fuel admission, cycle of operation, engine speed, engine starting in cold condition, engine cost, fuel consumption, fuel cost, maintenance. Based on these parameters, we have distinguished between petrol engine and diesel engine. Thank you for watching the video. Remaining part in this IC engine is about the problems. That is, we should understand about the efficiency. IC engine, if we break thermal efficiency, mechanical efficiency, so many formulas are there. Based on the formulas, we have to solve the problems. All these things will be done in the class. Okay, thank you.